We say that two events are independent when the occurrence of one has no effect on the occurrence of the other. So this means if I talk about two different events and knowing that one of them occurred has absolutely no effect on knowing whether the other one occurred, right? So my two events could be, I rolled a six-sided die and I get an odd number, and my other event is I drew a random card from a deck and I got a diamond card. Well, obviously, the roll of the die has no effect on the card that I pull. So those would be independent events. So when you are looking for the probability of both events occurring, if they are independent, then you simply get that by multiplying the two probabilities. Okay, if you want to know the probability that both occur, it's the product of those two probabilities. A random number generator selects three integers from 1 to 20. What is the probability that all three numbers are less than or equal to 5? So I have three events here. Okay, one event is the first number being less than or equal to 5. The second event is the second number is less than or equal to 5. And the third event is that the third number is less than or equal to 5. So I can use my rule for the probability of independent events and say that the probability that I'm just going to write like the probability that the first is less than or equal to 5 and the second is less than or equal to 5 and the third is less than or equal to 5. This is just kind of an extension of my independent events rule, and that's just I multiply these three probabilities. So that's the probability that the first is less than or equal to 5 times the probability that the second number is less than or equal to 5 times the probability that the third number is less than or equal to 5. So now I do each of these. These were independent events, right? The random number generator is going to randomly pick numbers. It doesn't matter what it picked for the first number. The second number is still completely random. So the probability that the first number is less than or equal to 5. Well, I'm picking numbers from 1 to 20, and there are 5 numbers less than or equal to 5. So this is going to be 5 out of 20. Times, well, here it happens again, right? The second number I pick, again, there's 5 ways it can be less than or equal to 5 out of the 20 numbers being chosen. And the same for the third number. Well, each of these is 1/4, so I get 1 over 4 times 1 over 4 times 1 over 4, which is 1 over 64. So the probability is of all three being less than or equal to 5 is 1 over 64.